Okay, so today we're going to talk about trig identities, trig cofunctions, and trig complement functions. As far as the trigonomic identities go, we're going to learn 3 of them. You have to have all 3 of them memorized. So, quick review. So write this down. You wrote this down on Friday. Don't forget your special angles. Okay, we have our 45-degree angles. We have our 60-30-degree angles. You already should have this written down in your notes right here, because this is what we did Friday. I just put it in a nice, neat table form for you. Here it's not so much in the table form. So again, we have these right triangle definitions of trig functions. And we've already talked about how the sine is opposite over hypotenuse. You guys know your SOHCAHTOA. And then we added to that cosecant, secant, and cotangent. And we said that the cosecant is just the reciprocal of the sine. So here under our trig identities, our first identity is the reciprocal identity. We're just formalizing that relationship that the cosecant is the reciprocal of the sine. Okay, so all this is doing is formalizing that relationship. All right, so where are we going to see these used? What we're going to use these for today is manipulating expressions. And then tomorrow we're going to talk about the applications. How do we really use these in real life? So today we're just going to talk about manipulating. Tomorrow we're going to talk about applying. Okay? Now your other identity is called your quotient identity. And your first quotient identity says if you just have the sine of theta and the cosine of theta, well, if you make the ratio sine theta over cosine theta, that's going to give you the tangent of theta. And the same thing with cotangent. Saying that cotangent is a reciprocal of tangent, you just reciprocate the ratio. So now it's cosine theta over sine theta is equivalent to the cotangent of theta. All right, so here's your first example. Given the following 2 trigonometric functions, use their values to find the remaining 4 functions. So I give you the cosine function. I say that the cosine of theta is square root of 5 over 3. And I give you the sine function. I tell you that the sine of theta is 2 over 3. So now we need to use those 2 values to find all of the others. And the first one that we're going to find is we're going to find the tangent of theta. And as we find the tangent of theta, we're going to use our quotient identity to help us find the tangent of theta. And the quotient identity tells me that the tangent of theta equals sine theta over cosine theta. All right, well, the sine of theta is 2/3. And the cosine of theta is the square root of 5 over 3. Now you guys know that you can't leave fractions inside fractions inside fractions. This is bad math. So what do I have to do to get rid of those fractions? You don't have to go quite that far into it. Okay, we can do multiply by the reciprocal. We can do keep, change, flip. And if we do keep, change, flip, we get 2/3 times 3 over the square root of 5. Now, what do you notice happens right now? The 3's cancel. We could have done that a step previous when we had 2/3 over the square root of 5/3. If you have a denominators inside fractions and the denominators inside the fractions are the same, you can cancel them right away. And so this leaves us with 2 over the square root of 5. Well, I can't leave it 2 over the square root of 5. I have to rationalize the denominator. So what is this equivalent to with a rationalized denominator? 2 square roots of 5 over 5. Okay. Okay. You guys should be at the point where you're multiplying the 2 over the square root of 5. You're multiplying by that, the square root of 5 over the square root of 5, mentally. You shouldn't have to write that out anymore. Okay. So now I have my main three. I have my sine, my cosine, and my tangent. So now I have to find my, up next, cosecant. So how do you find the cosecant of theta? Well, the cosecant of theta is the reciprocal of what function? The sine function. All right, so the reciprocal of my sine function is then 3/2. All right, up next we have secant. And secant is the reciprocal of which function? Cosine. All right. Theta? Because I have to keep the name of the angle in there. I'm talking about a very specific angle, angle theta. I could have put an alpha there, a beta there, but whatever it is, it has to be the same here and here in the original, and then I have to carry it through. It's just the name, so we know which angle we're talking about. So secant theta is 1 over cosine theta, which is 3 over the square root of 5, which is really... Very good. 3 square roots of 5 over 5. And then our last one is cotangent. And you guys know that cotangent is reciprocal of tangent. Okay, now we don't want to reciprocate our final answer up here to radical 5 over 5. Because if we reciprocate that, then we're stuck with a radical sign in the denominator, and then we have to re-rationalize my denominator. So instead, I'm going to go backwards a step to 2 over the square root of 5, and I'm going to reciprocate that, and that's going to give me the square root of 5 over 2. Because if I reciprocate this first one, 2 square roots of 5 over 5, if I reciprocate that, then I'm going to have this square root of 5 in the denominator. So I'm going to have to rationalize my denominator again, and then I'm going to have to reduce my fraction. So here, if I just use this one, I just plain old flip it, and we're done.
Wait, I have a question.
Sometimes it hiccups. All right, so your third one is your Pythagorean identity. These are going to be derived from the Pythagorean theorem, and on page 4, they show you the proof. I want everybody to go to page 504 tonight. I want everybody to read page 504, and I want you guys to look over the proof as to why these are called Pythagorean identities and why they work. Okay? So, our first example comes from our Pythagorean identity. So the first one, sine squared theta plus cosine squared theta equals 1, is probably the one you're going to use the most. As far as 1 plus tangent squared theta equals secant squared theta, a lot of the time, instead of using it in that form, we're going to be using it in the form secant squared minus secant squared theta minus tangent squared theta equals 1. Same thing for the last one. 1 plus cotangent squared theta equals cosecant squared theta. Most of the time we're going to work with this in the form cosecant squared theta minus cotangent squared theta equals 1.
Like the direction says what we have to do.
Right, well today we're manipulating. So your homework is going to say, you know, using this Pythagorean theorem, do this problem.
Then
Okay.
we should do like the 3.
No. So here, on this problem, find cosine theta given that sine theta is half. So of my 3 types of identities, the reciprocal identity, the quotient identity, and now the Pythagorean identity, the only formula of the 3 identities that involves nothing but cosine and sine is this Pythagorean identity right here. So if you're given just sine and asked to find cosine, you use this. If you're given cosine and just asked to find sine, you're just going to use this. Okay? So, which identity do you choose to use? It depends on what you're given. Okay, and we're gonna look at some more examples. Basically. All right, so find cosine theta given that sine theta is half. All right, so we're going to use sine squared theta plus cosine squared theta equals 1. Well, if sine theta equals half, what's sine squared theta?
Wait.
Half squared.
Why did you choose this one here?
Because it looks like a good example. Remember, right now we're just learning how to manipulate. Tomorrow is where we're going to see how this applies to like real problems.
No, I'm saying why did you choose that identity?
Why did I choose sine squared plus cosine squared?
Yeah.
I had to. Because sine squared, if you look at your reciprocal identities, if I'm given sine for my reciprocal identities, I can find cosecant, because that's the reciprocal. If I'm just given sine, then my quotient property does me nothing, because I need sine and cosine to find tangent. So here I've chosen sine squared plus cosine squared, because this is the only formula that explicitly deals with nothing but sine and cosine. So because it only has basically two quote-unquote variables, because I have the value of one of the quote-unquote variables, I can substitute in and solve for the other. So here, half squared is a fourth.
Oh, okay, so then you just do 1 minus 1/4 and then square root that.
So we subtract 1/4 from both sides. We do 1 minus 1/4, so it gives us cosine squared theta. And then you're absolutely right. To undo a squared, we square root. So we're going to square root both sides. So your next line is going to read
Cosine equals.
the cosine of theta equals the square root of 3/4. But I can't leave the square root of 3/4. I have to simplify. So the square root of 3/4 simplifies to be the square root of 3/2. Good.
Yeah, I have a question. You know how there's the things the things above the example, like equations kind of.
Uh-huh.
Will that be like given, or do we have to know that?
You have to have those memorized.
So when they give us like let's see that example, we will look at what we have with the identities and then see what like our variables are. And then
Absolutely.
Those that match, those are the ones we use
Right.
to find it.
Absolutely.
Okay.
So for example, here, we need to simplify cosine of 42 degrees times the secant of 42 degrees. So now looking at your three properties, reciprocal quotient and Pythagorean, which of the three involves an expression or quote-unquote formula that involves nothing but a cosine and a secant?
Would that be trig identities or like the
Well, which of the
plus cos theta equals 1 over
It would be a reciprocal identity. So when you come to this question like this on the homework, the first thing you're going to do is write down which identity we're using. So right now we're going to use the reciprocal identity. Because if you look at your identities, the reciprocal identity is the only one that has an equation that deals with nothing but a cosine and a secant. And in fact, the reciprocal identity tells me that secant of 42 is going to equal 1 over the cosine of 42. Okay, this is our equivalence statement that we get from our reciprocal identity. So what we're going to do is we're going to use this equivalence statement to make a substitution. So we're going to come up here and we're going to say that this equals the cosine of 42. Now instead of writing secant of 42, I'm going to write in what the secant is equivalent to. And what is the secant equivalent to? 1 over cosine 42. And if I have the cosine of 42 degrees times 1 over the cosine of 42 degrees, what's my answer? My answer is 1. So what is the cosine of 42 times the secant of 42? It's 1. So if you were to type into your calculator, cosine 42 multiply secant 42, your calculator is going to tell you that the answer is 1. Okay? But we're doing these without a calculator. Okay? Questions on example 1? Go ahead.
For the cosine and secant one,
Mm-hmm.
are they always, like, if it's any reciprocal, are they always going to equal 1?
Well, yeah, because what happens when we multiply reciprocals?
Oh,
It always equals 1. Good. And that's a really good observation. Anytime you have two functions that are reciprocal functions and you multiply them, when you multiply reciprocals, you get 1. All right, so now which identity is going to help us simplify the following? Sine squared of 3 pi over 10 plus cosine squared of 3 pi over 10. Well, which of our identities deals with nothing but a sine squared and a cosine squared? My first Pythagorean identity. So my very first Pythagorean identity says I'm having serious spelling problems today. Okay, so my Pythagorean identity says that sine squared plus cosine squared of a theta equals 1. So sine squared of 3 pi over 10 theta plus cosine squared of 3 pi over 10 theta. Because these are the same two angles, that means that when I add them together, I get a sum of 1. So if you had your calculator set to radians, which you don't, and you put in sine squared of 3 pi over 2 radians plus the cosine squared of 3 pi over 10 radians, you're going to get an answer of 1. Questions?
So if they're the same, you're always gonna get 1.
Don't go by that as the rule, but you're going to see 1 pop up a lot on your homework tonight just because we're learning how to manipulate so that we can learn how to use tomorrow.
But I don't even understand how you do that.
All right, so those are our our three trigonomic identities: Pythagorean identity, reciprocal identity, and quotient identity. So now we're going to talk about complements. You guys know the definition of a complement.
Yeah.
Two angles are complementary if they add to 90. So now think about what we're working with. We're working with right triangles. Well, triangles have a total of 180 degrees in them. So if one of the angles has 90, then the other two have to add to 90. So that makes them complements. Okay? So what we're doing is, because we're talking about these complement relationships, we can use them to pair each function with its quote-unquote cofunction. So when we're calculating sines and cosines and tangents and cotangents and secants and cosecants, how are those related? Well, this is that the sine of an angle equals the cosine of its complement. Okay, and that's always true. So for example, if I'm finding the sine of a 70-degree angle, that's the same thing as finding the cosine of a 20-degree angle. Okay? Again, we're just manipulating right now. We're going to talk about applying tomorrow. So our first example says find the cofunction for the sine of 46. So what is the cofunction of sine? Cosine. Okay. So my cofunction here is going to be the cosine of the complement. So it's going to be the cosine of 90 minus 46. This parentheses that you put around the 90 minus 46 is very important. If that parentheses isn't there, that would express, find the cosine of 90 degrees, and then subtract it by 46. Okay, so that parentheses right there is a very, very, very important parentheses. All right, so that simplifies to be the cosine of 44. So again, if you were to type into your calculator sine 46, and then you were to type into your calculator cosine 44, you're going to get the exact same value. But again, we're doing this without calculators. All right, the cotangent of pi over 3. Well, what is the cofunction for cotangent? Tangent. All right, well, I can't say 90 minus, so I have to use the radian equivalent of 90, which is pi over 2. So I'm going to take pi over 2
Or you could switch into the
minus pi over 3. No, you never want to switch back and forth between radians and degrees.
Why?
Oh, wouldn't that just be,
So why would it just keep 90 and then change that to whatever pi over 3 is? Like in degrees?
No, if you're given radians, you want to stay radians. You want to not be in the habit of switching back and forth between radians and degrees in the middle of one problem, and that's leading somewhere like next year. All right, so how do I subtract fractions? Same denominator. So the common denominator here would be 6. So pi over 2 is equal to what over 6? 3 pi. And pi over 3 is equal to 2 pi over 6. So 3 pi over 6 minus 2 pi over 6 is just the tangent of pi over 6. So the cotangent of pi over 3 and the tangent of pi over 6 are going to give you the same values.